As we look further at right triangles, we come across our special right triangles. And our special right triangles we identify as a 45-45-90 triangle, a triangle with two 45-degree angles and a right angle, and then the 30-60-90 with a 30, 60, and a 90 degree. Now, these two triangles are special because they're actually similar to all other triangles with the same angle measures. So if we think about it, back when we did similarity, we had angle-angle similarity. And in this case, we can have two sets of angles match, the 45s or a 45 and a 90. That means that it's going to be proportional in sides in terms of all other similar right triangles with 45 and a 90. So that's going to help us as we go through and solve. Now it also mentions that it has a ratio here of 1 to root 2. And that tells us that the hypotenuse is going to be root 2 times the leg. And this is normally the rule that we use as we go through and solve, but I want to take a different approach. What if we just use this triangle and we take that triangle and make it a similar triangle to all other 45-45-90s and solve with proportions? Then we don't have to remember the rule and we can take this triangle wherever we go and we're able to solve. We're going to do the same thing with a 30-60-90. We're going to take this triangle and use that as our tool to then apply it to any other 30, 60, 90 triangle. Now this one, the longer leg is the root 3 times the shorter leg, as indicated in the ratio and the triangle. And the hypotenuse is 2 times the shorter leg. So the shorter leg is connected to both other values in terms of the rule. Longer leg and hypotenuse, it's not as clean as remembering their relationship. But we're going to use that triangle, and that's going to help us a lot. Now, in this, we have that the 30 degrees is opposite to 1. 2 is the hypotenuse, so it's double the shorter leg. And then the root 3 is the longer leg. And where that comes from is if I had the 1 and the 2, we know it's root 3 because of Pythagorean theorem as we solve. Well, where did we get that from? Let's take a further step back. What if I had an equilateral triangle where all the sides were 2? I then drew a perpendicular through the center that cuts it in half. It's a perpendicular bisector. I would then have the 1s to give me 2 and 1. Now what I'm looking for is the height. That is my unknown side. That's the longer leg in this scenario. So this is going to be 2 squared equals 1 squared plus x squared by Pythagorean theorem, which as we solve gets us to 3 equals x squared, or x equals root 3. So it's really based in an equilateral triangle, which is where we get this rule. So as we go through and solve, these are the two triangles we're going to use throughout. So first problem. Top row is all 45-45-90s. I am going to draw my reference triangle such that it is facing the same direction as the triangle I'm solving for. In a 45-45-90, I remember those values, 1, 1, root 2. Now, before we get too far, we do realize that this is an isosceles triangle when it's a 45-45-90, so that does mean that x is 8. So let's get that out of the way. They are the same value, and even the ratio shows they're both 1s. But now we need to solve for y. So I can write the proportion 8 over 1 equals y over root 2. Now from here, in proportions, we just do cross product. And y times 1 is y, and then we get 8 root 2, which is what y is. So that gives us our answer. Now if we go back and look at it a little bit more, we can see that scale factor in similarity is at play here because this triangle is 8 times bigger than this one. It's the scale factor that got 8 times larger. But we have our two values. Let's do another one. Now I'm going to draw my triangle facing the same direction, 1, 1, root 2. Here we should know that y is also 25 because it is isosceles, so we have that. So I'm going to go 25 is to 1 as x is to root 2. So again, by cross product, 1 times x is x, and then 25 root 2 is our answer. So in this case, we could say that our triangle is 25 times bigger than the reference triangle. It's a scale factor of 25. Now those were kind of nice. Well, what if I have a whole number on the hypotenuse? It gets a little bit different and we have to use a little bit more of our radical skills here. and not radical as in radical. Awesome radical, but radical as in square roots. So we know x and y are going to be the same. They're both 1. Okay, those are going to match. So I just need to find x. So I'm going to go 19 over root 2. 19 is to root 2 as x is to 1. Which looks like a proportion that we have to solve for, but really x over 1 is just x. So it's 19 over root 2. And that's kind of our answer. One thing we do have to do though is we have to simplify the radical. We have to rationalize the denominator because you can't leave a radical in the denominator. So to fix that, we multiply top and bottom by root 2, which gives us 19 root 2 over 2. That is our answer for x. And then since we said it is isosceles, that is our answer for y. All right, moving down. We have our 30, 60, 90. So I'm going to draw in the same order. I know 30 is here, so short side is 1, hypotenuse is 2, longer leg is root 3. So the easiest one to match and solve for is probably going to be y, because y is matching to 1. So I'm going to go 46 is to 2 as y is to 1. I don't even have to do cross product here because I can just simplify the two fractions. 26 divided by 2 is 23, and that just becomes y. Now, if y is also 23, I can kind of look and see here that it looks like it's 23 times bigger. That's the scale factor, scaling it up to match. So let's solve for x. So I know 23 is to 1, that's the new y value we have, 23 is to 1, as x is to root 3. By cross product, we get x equals 23 root 3, which is our answer. And here we start to see that the longer leg, the x in this case, is root 3 times the shorter leg. So if this is 1, this is 1 root 3. If this is 23, this is 23 root 3. And that's something that does hold up as we go. So let's look at our next one. 1, 2, root 3. So I have to go 20 over root 3 is equal to, I'm thinking y is going to be easier to solve for first. So I'm going to go y over 1. Well, that already tells me that y equals 20 over root 3. We have to rationalize by multiplying top and bottom by root 3, and we get 20 root 3 over square root of 9, which is 3. Now I could substitute back into the proportion here, but I also noticed that x is going to be twice the value of y because it's a 1 to 2 ratio. So that means x is twice this value. And to find that, I'm just going to double the 20 and make it 40 root 3 over 3. Be careful here because sometimes students want to make it 40 root 3 over 6, but if you double both the 20 and the 3, it still reduces back to be 20 over 3, which did not change at all. Alright, last one here on the screen. I'm going to draw my reference triangle. We have 1, 2, root 3. Now from here, I see that, well, 9 root 3 and root 3, those match. So let's go with this. 9 root 3 over root 3 equals x over 1. Well, root 3 divided by root 3 is 1, so that's gone. And I'm left with x equals 9. But then y, in this case, since it's 1 to 2, it's twice the length. Y is twice of what x is. So that's 18. Could have also said, well, x is 9 over 1 equals y over 2, and you would also get y equals 18 by your proportion. Alright, next here we have a 45, 45, 90. I know that's isosceles, so that's automatically x is 4. So we go 1, 1, root 2. So let's go y is to root 2 as 4 is to 1. By cross product, we get y equals 4 root 2. Next one, the hypotenuse is 28, so we're going to go root 2, 1, 1. 28 is to root 2 as x is to 1. Now x and y are going to be the same here because it's isosceles. So this gives us x equals 28 over root 2. I'm going to rationalize by multiplying the top and the bottom by root 2, and I get 28 root 2 over 2, which now I can divide the 28 and the 2. I can reduce that, and it becomes 14 root 2. So that's x, and since it's a 45, 45, 90, and it's isosceles, that is also y. For our next one, we have a 30, 60, 90, 1, 2, root 3. So here we're going to go 15 root 3 over root 3 equals x over 1, because x is going to be nicer to solve with. Now from here, 15 root 3 over root 3 just becomes 15. So x equals 15. Now if x is 15, we could say 15 over 1 equals y over 2. By cross product, you get that y is 30. Moving on, we have our 30, 60, 90, 1, 2, root 3. We're going to go 6 over root 3 equals y over 1. So this gives us y equals 6 over root 3, which we're going to multiply top and bottom by root 3. That's now 6 root 3 over 3, or 2 root 3. Now I could double that to get x because it's that 1 to 2 ratio, but I'm going to write the ratio out. So I know y is 2 root 3 over 1 equals x over 2. By cross product, I get x equals 2 times 2 is 4 root 3. Okay, for our last set here, now I'm starting to put multiple triangles together. So first one, I have to do the 30, 60, 90 at the top here. So I'm going to go 9 over 1 equals z over 2, and that gives me that z equals 18. Next I'm going to go 9 over 1 gives me this mystery side, let's call it w, just because we need a letter. 9 over 1 equals w over root 3. Now that gives us that w is 9 root 3. Now it's not really something we're solving for, but let's just write that in now, because now we can use it. 9 root 3. So now we go to our reference triangle on the bottom, which is the 45, 45, 90. And we're going to draw that one out. We got 1, 1, root 2. So 9 root 3 over root 2 equals x over 1. Well, it's already kind of in order for us. So we have x equals 9 root 3 over root 2. We multiply top and bottom by root 2, and we get 9 square root 6 over square root of 4, which is 2. Not going to simplify because 9 and 2 does not reduce, but that's going to give us x, 9 root 6 over 2. That also gives us y, because again it is isosceles. Next problem, we're going to use our 45, 45, 90 to solve for x and our unnamed side here, because it is isosceles. So we go 1, 1, root 2. So let's go x over root 2 equals 32 over 1. By cross product, we get x is 32 root 2. Got that? Okay. Now we need this mystery side. Well, it's a 45, 45, 90, so it's isosceles. It's isosceles with the 32. So that was easy. Got that. Now we're going to draw our 30, 60, 90, 1, 2, root 3, and say that 32 is to 2 as z is to 1. Well, that simplifies to give us that z is 16. Now if we have that, we could say 16 is to 1 as y is to root 3, and by cross product we get y is 16 root 3.